Hey everyone, welcome back. So today's topic, data types in Java. So one more thing, this video is going to be a little bit long. So before we discuss all the topics, let's just quickly go through what we are going to discuss in this video. So firstly, we will see what is a data type. Then we will discuss types of data type. There are mainly two types of data type, primitive and non-primitive. Then we will classify the primitive data types and we will discuss them in detail. Then we will see how to find ranges of integral types. This is a very important topic. So wait for that. Then I'll give you overview of various reference types. So I'll just briefly explain what are various references present in Java. Then this again is the most important point: value types versus reference types. Actually, the primitive types are also called value types, and non-primitive types are also called reference types. You'll get this topic, don't worry, because I'll show you the memory representation also. Okay, so there's a lot to discuss. So without any further ado, let's hop in. So what is a data type then? Data type specify the set of values that a variable can hold. In simple words, data type of a variable decides or specifies what are the permissible values that that variable can have. For example, if the type of variable is of integer, it can only hold whole numbers. It cannot hold any decimal point numbers or any boolean numbers. Okay, if I have an integer variable, I cannot store a true value in it. Simple. Different data types have different sizes associated with them. In simple words, this means is every data type are represented in a different manner in the memory. Okay, this will be more clear if I give you an example. Consider we have two variables, num1 and num2, and the data type of them are respectively data type 1 and data type 2 respectively. Okay, and there are values like value 1 and value 2. I don't care what are these data types and what are these values, but the main thing you need to focus here is the size of data type 2 is double than the size of data type 1. So what does this mean is the value 2 will actually occupy double the size than the value 1. And why is that? Because the size of data type 2 is double than data type 1. So let's just see the memory representation of these two values. Okay, so consider this abstract representation of memory, and these are all the memory cells. This is 1, 2, 3, 4, and so on. I cannot represent every memory cells because due to the limitation of the space, but you got the point, right? So how will be this stored then? If value 1 by chance somehow occupies one cell, okay, let's just consider that the size of this one memory cell is equal to size of this data type 1. So the value 1 will occupy the one memory cell in the memory. Now, as the value 2 is double than the size of value 1, it will definitely occupy two cells. Simple, right? So what is the crux then? Data types specify the set of values that a variable can hold, and different data types have different sizes associated with them. That is to say, they have different memory representation. Okay, let's move on. In Java, every variable or expression has some type associated with it. Yeah, this is a very important statement. Just a second, I will elaborate this point, but I have to discuss one more point here. Every assignment is checked by the compiler for type compatibility. Uh, this point says that whenever you assign a value to a variable, the compiler checks if that value is valid or not. The same case I told you earlier. We cannot assign a decimal point number to integer. The compiler will throw me an error. So the compiler checks for type compatibility every time we perform an assignment. And this is the reason why Java is also called strongly typed programming language. So let me just explain these two statements in code so it will be more clear to you. Okay, so the first statement told that every variable has or expression has some type associated with it. Now consider this variable num1. It is a integer type associated with it. Okay, it needs to have a data type. If I remove this data type, the compiler will throw me an error. You can see the compiler throws me an error, cannot find symbol. It is not able to recognize that variable only. So of course, every variable needs to have some type associated with it. Cool. And the next statement, every expression also needs to have a type associated with it. So what is expression then? In simple words, expression is a bunch of variables connected to each other via operands that convey one value. Okay, so what are these? These are a bunch of variables, right? And they are connected by operators, and they convey one value. And what is that value? This num2 is 20, this num1 is 10, and this 50. So 10 plus 20 plus 50, it is 80. So it's an integer, right? So this expression actually, this num1 plus num2 plus 50, actually represents a value, and that's 50. And what is that value? It's integer. That's why I'm storing it as an integer variable. So the point is clear. Every variable or expression has some type associated with it. The next point, the compiler checks for type compatibility. So what do I mean by that is, if this is an integer variable, I can only assign an integer to it. I cannot assign a decimal point number like 10.5. If I do that, the compiler will throw me an error. See, it says incompatible types. That is, I'm trying to assign a value that is not a whole number to the integer variable. Similarly, if I try to assign it a different value, like something like true, okay, let me just run it again. The compiler again throws me an error. Incompatible types. It is this type is not valid for this variable. So I guess these 2 points are clear then. Every variable or expression has some type associated with it. Every assignment is set by the compiler for type compatibility. Let's move on. Data types are mainly divided into two categories, primitive and non-primitive. What are these primitive data types? These are the most fundamental data types. That is, they are part of core language. They are most basic data types. And what are these non-primitive data types? They are basically derived data types. They are actually derived from these primitive data types. Okay. And one more thing, you just remember this. Primitive types are also called value types, and non-primitive types are called reference types. I'll come to this point later in this video, but just try to remember this point for some time. Okay, we'll discuss this in detail. So what is the crux of this slide then? Every variable or expression has some type associated with it. Every assignment is checked by the compiler for type compatibility. You cannot randomly assign values to the variable of any type. There are mainly two types of data type in Java, primitive and non-primitive. Primitive are the most fundamental data type. Okay, the most basic data types. And non-primitive, these are derived data types. That is, they are derived from these primitive data types only. Okay, and primitive types are also called value types, and non-primitive types are also called reference types. Let's move on. So let's discuss this primitive types then. These are the basic building blocks of data manipulation. Yeah, I told you, these are the most basic data types available. Okay, we can store most fundamental types of data like numbers, characters. Yeah, we can store fundamental data types like numbers. We can store whole numbers or decimal point numbers or characters and so on. So let me just classify these primitive types then. Primitive data types are mainly classified into two categories, numeric and non-numeric. As the name suggests, numeric data types will hold the values that are numbers, and a non-numeric will contain all the non-numeric values. Simple, right? Okay, let's just discuss them in detail then. We have two non-numeric data types, char and boolean. In char, we actually store single characters. For example, anything can be a single character. For example, this all the lowercase letters, all the uppercase letters, or special symbols like exclamation mark or at the rate or the pound symbol. Even the space is also a character. It needs to be a single character, right? And this boolean just represents two values, either true or false. Don't worry, we will discuss their values, what values they can have in the later video when we discuss about literals. But I'm just trying to give you an overview of what type of values they store. Okay. So here, this numeric types can further be classified into two more types, integral and floating point. Now, integral data types will contain only whole numbers. That is, the decimal point is not allowed here. Okay. For example, 1, 2, 3, like 10, 15. This decimal point is not allowed here. And the floating point data types will contain all the data types that may contain decimal point. For example, 10.5, 4.5, minus 10.5, and something like that. So these are the four integral data types available in Java, and these are the two floating point data types available in Java. One more, most important point here is all the data types except char and boolean are signed data types. What I mean by that is we have both positive and negative values in these numeric data types. That is, we can have something like minus 10 and plus 10. We can have something like minus 4.5 plus 4.5. But there is no terminology like here in non-numeric data types. We cannot have something like this minus exclamation mark or minus true or plus false. They just have some value. Simple. So I hope this line is clear, right? So what's the main crux of this slide? There are the primitive data types are classified into two main categories, numeric and non-numeric. Numeric is used for storing numbers and non-numeric is used for storing values that are not numbers. Simple. So there are two non-numeric data types, char and boolean, and there are the numeric data types can be further classified into two more categories, integral and floating point. Integral we have four data types possible, and in floating point we have two data types possible, float and double. So let's just discuss this integral data types in detail first. Okay, integral data types. So we have four integral data types present in Java, and they are byte, short, int, long. And what does this size mean is the number of we can say the number of memory cells, or it will be better to say the amount of space that it occupies in the memory. The byte occupies 1 byte space, the short data type occupies 2 byte space, the int occupies 4 byte space, and the long occupies 8 byte space. Okay, for example, if your integer value like 10, it will occupy the 4 bytes in the memory. So of course it will be stored in binary, but you got the point, right? These are the sizes. Now we have to just learn a different topic now. How to derive these ranges. So these ranges at first seem quite intimidating, but it's not. It's very easy to derive these ranges. So instead you mug up these ranges, it is better you learn how to derive them, right? So let's just derive these ranges then. Now in order to derive these ranges, you need to understand this point. Now the size of byte data type is 1 byte. So what does that mean actually? It doesn't necessarily mean there will be something like a memory cell of 1 byte, and for example your byte variable which is having a value 4. It will be not like that there is a memory cell of 1 byte and the 4 will be kept there. Actually there will be a memory cell of 1 byte, but actually it will be further divided into small little quantum blocks. Okay, and this 4 will be actually stored in binary. Okay, so what I'm trying to say here is the number, or we can say the value, will be stored in the form of bits. So what is a bit then? A bit is, you can say, the smallest unit of information. That is, you can say the smallest information can be represented in the form of bit. You might have heard this term, right? A bit can take only two values, either 0 or 1. So let me just repeat again what I told. All the values will be stored in the form of bits. For example, we have this 1 byte, right? We'll be having something like this byte variable, like a, let's just consider this declaration, byte number equals to 4. Then this 4 will be stored in the form of 8 bits. It won't be stored directly like 4. Okay, so it will be just converted into some binary form, and then it will be stored in these 8 bits. It will be something like that. Okay, and as we know, a bit can take only two values. So 4 will be stored in these 8 bits, and each and every bit will have either 0 or 1. Either 0 or 1. Okay, makes sense? I think so. I know it's a little bit it's what I can say. It is a little bit tough to understand at the first sight, but just rewind the video, you will understand what I'm trying to say here. Okay, so let's just derive the ranges. So how this range will come then? If we found out how many total number of combinations are there. So what are the combinations is how many ways we can arrange 0 and 1 in these 8 bits. We'll be able to find out that how many numbers are possible. Make sense? So what I'm trying to say here is, at this first position, we'll be having two options. Either we can store a 0 or we can store a 1. Okay. Similarly, for the second position, we'll be having two options. Either we can store a 0 or 1. In the third position also, we'll be having two options. Either we can store a 0 or 1. And similarly, for all the 8 bits, we'll be having two options. Okay. And from the fundamental principle of counting, how many total combinations are possible? 2 into 2 into 2 into up to 8 times. So there will be total 2 power 8 combinations possible for a 1 byte memory location. Okay, so there will be 2 power 8 numbers that I can represent using this 1 byte. So if we have size of 1 byte, we can actually represent 2 power 8 numbers. So if you count this, I won't waste your time. They are actually 2 power 8 only. They are 256 values only. I don't think so you understand it completely. So let me just repeat it again what I told. What I told is, every number in the memory will be stored in the form of bits. For example, this byte is a 1 byte size, right? So it will be broken down into, as we have 1 byte equals to 8 bit, it will be broken down into 8 bits. Okay, so the number will be stored in the form of bits, and a bit can take only two values. Okay, so what we are trying to find here is, we are trying to find how many maximum numbers can these 8 bits represent? So then we can start dealing with this range. Okay, so first we need to find out how many numbers can this 1 byte represent, 1 byte or 8 bits. Okay, so what we did is we found out that for every bit we can have only two possibilities. So from the fundamental principle of counting, as we have two possibilities here and two possibilities in the second position and third position and so on, we found that there are total 2 power 8 combinations. Simple. So let me just give another example if you don't understand this method. Okay. So consider a small example. In this way, only 3 bits. Okay. Let's just find out how many combinations are possible when we have only 3 bits. For example, consider a arbitrary data type which has a size of 3 bits. Okay. So let's just see how many combinations can be possible there. So you can relate it with that 8 bits. Okay. So in the first bit, these are just headings. I'm just below this. I'll write the number of values possible for these bits. Okay. Don't worry, you'll understand that. So for the first position, I'll be having two options. Either I can have 0 or 1. Simple. Now, depending on what I select here, for example, consider I select this 0 here. I just put 0 here. Okay. Pardon for my handwriting, but you got the point, right? So if I choose 0, then again I'll be having two options for the second bit. Either I can choose 0 or 1. Okay. Now let's just consider I choose this 0 again. Then again I'll be having two options in the third bit, either 0 or 1. But I may have selected this one. Then again I'll be having two options in the third bit, either 0 or 1. Now initially I might have choose this one. Then again I'll be having two options in the second bit, either 0 or 1. Now let's just say if I've selected 1 here, then 0 here. Again I'll be having two options, either 0 or 1. So I think you know where we are going, right? Let's just extend it further. This last is also pretty obvious, right? So we can say how many combinations are there. So this one combination, right? 0 0 0. This is another combination, 0 0 0 1. This is one other combination, 0 1 0. So how many total combinations are there? We just need to count these boxes, right? 1 2 3 4 5 6 7 8. So there are actually, we can say, 2 power 3 or 8 combinations when we have 3 bits. So that is to say we can represent 8 numbers when we have 3 bits. So I think now you got the terminology. Okay, if you still don't get it, please rewind and watch the video again. You'll definitely get this point. So what we conclude here is, if we have n bits, we can simply represent 2 power n numbers. Here we have 3 bits, we are able to represent 8 numbers. In the previous slide, okay, if it lets me to go back, okay, we have here 8 bits, so it will be able to represent 2 power 8 combinations. For the case of int, we will be able to represent, if there are 4 bytes, so there will be 32 bits, because 4 into 8, so we will be able to represent 2 power 32 numbers. Okay, so I guess that makes sense. So let's just discuss how these ranges come then. Okay. Okay, let me just quickly go through this. Okay, so we have a byte data type, right? And its size is 1 byte. And we just found out for 1 byte, we can have 2 power 8 combinations. So if the size is 1 byte, we can represent 2 power 8 numbers. So as we know that this integral data types are actually signed data types. Okay, so we can represent both positive and negative numbers. So of course, I need to represent this 2 power 8. I need to divide this into two groups to say. Yeah, I have to divide into two groups. That is 2 power 7. I will just divide it 2 power 8 into two groups, 2 power 7, 2 power 7. And in one group, I'll represent all the positive numbers. And in one group, I'll represent all the negative numbers. Make sense? So 2 power 7 will contain all the positive numbers, including 0, and 2 power 7 will contain all the negative numbers. Of course, I need to include 0 somewhere, so let's just include it with all the positive numbers, right? So, one last point. For example, consider we have 5 non-negative numbers that start from 0. How will you write them? You will write something like this, like 0, 1, 2, 3, 4. So, how did you write? You write 0 through 5 minus 1. If you want to find 3 non-negative numbers that start from 0, you write something like this, right? 0 1 2. So you write 0 through 3 minus 1. So if you want to represent this 2 power 7 numbers, that is, these are non-negative numbers that start from 0, we'll write something like this, 0 to 2 power 7. Okay, And for the negative numbers, it's simple, -1 to -2 power 7. So I guess now you got it, how these ranges are formed, how this -2 power 7 to 2 power 7 -1 came. Let me just quickly go through what I just told. We have byte data type, its size is 1 byte, so it will be further divided into 8 bits. And for 8 bits, we can have maximum 2 power 8 combination. That is, we can simply store 2 power 8 numbers. Okay, I'll divide into two groups because I have to represent both positive and negative numbers. In one group, I'll represent all the non-negative numbers including 0, and in one group, I'll store all the negative numbers. Okay, and the 2 power 7 positive numbers including 0 can be this 0 to 2 power 7 -1, and all the negative numbers starting from -1. And if the total numbers are 2 power 7, we can represent like this. Simple. The similar explanation can be hold true for the short data type. Okay, so we'll be having, as there are 2 bytes, there will be having 16 bits. So we'll be having maximum 2 power 16 numbers possible. Okay, so 2 power 16 can be again divided into two groups, 2 power 15, 2 power 15. One group will contain all the non-negative numbers and one group will contain all the negative numbers. And simple, as they are all negative numbers starts from 0, we'll be having 0 to 2 power 15 -1 numbers, and the negative numbers will be -1 to -2 power 15. Simple as that. Okay, so that was actually a hell lot to swallow. So I would consider that you should take a break and then just replay the video. Okay, for me, let's just move on. Okay, so let's discuss the floating point data type. So there are only two floating point data types available in Java, float and double. And the size of float is 4 bytes. That is, it will actually take 4 byte size in the memory, and double will take 8 byte size in the memory. And these are the ranges. Okay. Now I'm not going to derive the ranges because it requires a little bit prerequisite knowledge, and it's out of the scope of this video. Okay. And this float is also called single precision, and double is called double precision. This simply means with the double you can represent more accurate values. Okay, that's all you need to know about float and double for now. One more thing I want to remind this thing again. What type of values that these variables can hold will be discussed in the next video when I discuss about literals. But for this video, I'm just going through all the data types that are present in Java so that you get a general idea of what are the data types present in Java. Okay. And one more thing, these are also signed data types, so they can hold both positive and negative values. So what is the main thing? There are two floating point data types, that is for storing floating point numbers like 10.5, 4.5, something like this. Float and double is more precise, it's more accurate. Okay, so let's end our discussion on primitive data types by discussing all the non-numeric data types. So there are only two non-numeric data types available in Java, char and boolean. So the size of char is 2 bytes and its range. Now this is a little bit homework for you. It's 0 to 2 power 16 -1. A little bit hint. We don't need to divide the 2 power 16 combination into two groups because these are actually unsigned data types as told earlier. There is no terminology for like negative numbers here. Okay. And this is important. This is interesting here. Boolean. The size of boolean is actually not applicable. It depends on different system. And the range, this is important one, remember that. The size of boolean is not applicable. It depends on the system. And there is no range of the boolean, and it is pretty obvious because we can only represent two values in boolean, either true or false. So there is not much to discuss here. One more important thing, char data type store all the values in Unicode format. Now I'll come to this Unicode in the next video, so wait for that. But I guess that's that. For the non-numeric data types, there are only two, char and boolean. Char is used to represent all the characters and boolean is used to represent the two values, either true or false. Okay, let's discuss the last topic of the video and the most important topic. What are value types and what are reference types? Okay, so one more thing, I just forgot to give you the overview of the non-primitive data types present in Java. So the different non-primitive data types present in Java are arrays, strings, user-defined classes. I'm not going to discuss them in detail because it's just out of the scope of this video, but we'll discuss all those data types one by one. Okay. So this primitive types are also called value types, and this non-primitive types are also called reference types. Okay. So what is the difference between them? Let's just see. If a variable is of value type, it will store its data value in its own memory space. But if a variable is of reference type, it will store the address of its data value in its memory space. Of course, this doesn't make any sense here. So let me just give you a visual representation. So consider we have two variables, x and y, and x is a value type variable and y is a reference type variable. Okay, so let's just see this x here. What does the value type mean? It will store its data value in its own memory space. That is to say, the memory that is allocated by the system for this variable will contain its value. Okay, for example, if the system allocates some byte memory for this x variable, then that memory will actually contain the value of x. Simple. So in other words, x is the alias for this memory location. There is no need to explain stuff. There is no need of more explanation here, right? The memory that is allocated for this variable will directly hold its value. Simple. So x is basically an alias for this address. Okay, instead of using the address to access the value, why don't we give it an alias? Okay, just it's like giving a label to this address. But in case of reference type, it will actually store the address where its data value is present. That is to say, the memory that is allocated for this y won't contain the value, but it will contain the address where its value is present. This is a little bit tricky here, right? In this case, if it's a primitive type, the memory that is allocated to this variable will directly contain its value. So x directly holds its value. But in case of y, that is a non-primitive type, that is a reference type, it will basically contain the address where its value is present. Okay, so in this memory space, y will contain the address of its value. And I can prove you this point. Let me take an example so that this points will be very clear. Okay, so here we go. So here a variable num2 defined as an integer. So when I try to access this variable, we can directly access it, right? There is not much of issue because it contains its value directly. Whatever the memory that is allocated to him, the value is stored there directly. So we have given just a alias to that address. But in case of a non-primitive type or reference type, for example, consider I have just created a student empty student class here, and let me just create a object of this student. Student is equals to new student. So if I try to print s here, this s actually won't contain any value. This s will actually contain the address, and I can prove you this point. Why? If I spell student correctly, I'll definitely able to show you. Okay, here you can see something like this printed. Student, it just represented the class student, and at the rate this 2A139A55. So what is this? This is actually the address where this actual student value is present. Okay, this is actually the address of this. What I mean by that is it is containing this address, something like this. It will be containing this address. So the value that we got here is this 2A139A55. It basically contains the value of that student variable. So I think it makes sense. So we summarize here 2 points. The value types will directly hold its value to his own memory space. That is the memory allocated by system. And the reference type will contain address of its value in its memory space. I think it makes sense. Okay, that's it then. It was a long video. Thanks for staying until the end. And of course, thank you for watching.